Hi everybody. In this video we're going to explain how to solve kinetics problems for a rigid body using momentum and impulse method. First, let me just go overview the definition of momentum to remind you. Momentum, we have two types: linear momentum, angular momentum. Linear momentum, if you have a mass and this mass has a velocity v, so the linear momentum will be equal to the product of the mass times the velocity of this body. The angular momentum, we have here a body which is rotating about a fixed axis, and the angular velocity is equal omega, and the mass moment of inertia is equal I. So the product of mass moment of inertia I times the angular velocity will give the angular momentum. Simply, they are so similar. Instead of mass and linear momentum, we're using mass moment inertia. Instead of linear velocity, we're using angular velocity. Well, the impulse, we have two impulses. One is called linear impulse and the other is called angular impulse. What is the difference between both? If you have a mass, you have a block, and there is an external force F applied to this block at time t1, and it continue till the time t2. During this period from t1 to t2, there is impulse imposed on the system by this external force. How can you calculate it? It's by, if the force is constant, you multiply the force by the time period t2 minus t1. If it's not constant value, so you integrate the force with respect to time, and we give it the letter P to represent the linear impulse. The angular will be similar to the linear impulse. You will have a body rotating about a fixed axis, as you see here. So it will, and there is external moment that apply to the body. So the angular impulse will be the product of what? The moment, this external moment, time the time period that it has been applied. For example, this disk at T1, we applied the moment M and continue up to the time equal T2. So how can we find the impulse, or how we can calculate the impulse, the angular impulse? We multiply this external moment by the period of time that has been applied, which T2 minus T1. Very similar to the linear one. Linear one, the force, here the moment. And the period of time T2 minus T1, T2 minus T1. If the moment is not fixed, is not constant, so we did by integration. We'll give it the tau to stand for angular impulse. So these are the two concepts that we're going to use in this lesson. If we have the principle of linear impulse and moment, if we have a body and this body has moved from position 1 to position 2, okay, but during this period, it starts with velocity v, all right, and it has also angular velocity omega initially, and then there is a force applied for a certain period of time. So this will cause impulse. So if you add the impulse to the initial moment for the system, the resultant one at the final stage will be equal to the sum of both. So we can say simply by this equation, L1, the linear momentum, at the initial position, initial time, add to this the impulse, the sum of the impulse caused by external forces will give us the final value for the momentum. So I just write in this equation that the initial momentum plus the sum of the impulses will be equal to the final momentum. Of course, this is general one. You can break it into two components, one for the x component and one for the y component. You make a resolution for this. So you will have momentum in the x direction plus the external force in x direction that cause impulses. The sum of them will give the final momentum in x direction. The same thing can be done for the y component, okay? So that was like translation from one place to another. And if you are talking about the principle of angular impulse. So this one is rotating, and you apply the external moment m. So h stands for the initial, h1 it stands for initial momentum. And when you apply external moment, you see here the red arrow, that's like you have a motor or something that apply moment. So this will cause angular impulse added to the initial momentum, and then in the end you will have the final momentum here. Observe that if you put a block here just to in the top on the initial position 1, you will see in the end it will move, by certain angle. So simply also we are using the same equation. Initial momentum plus the sum of the impulses caused by external moment will be equal to the final moment here. Simple equations, okay? So what about if it's something rotating about a fixed axis? So it will have both. It will have linear momentum and it will have also angular momentum. So the angular moment, the linear momentum in x and y component, the same as we explained before. Add to this the angular momentum. Why? Because if this body, if you look at it, if it's rotating about a fixed axis here, so it is to rotate, g will transfer, means g will also have translation, and at the same time also rotating. So you apply both principles, the principle of linear momentum and the angular momentum. So the three equations will be applied. Sometimes we can find only one component, x or y, or we can have both, but in both cases we'll have linear and angular. All right, so let's just solve this problem. Let's go to our notes to take a copy. In this example, we have a ball, and this ball, the radius is given 100 millimeter, which be converted to meter, will be 0.1 meter, and the mass is equal to 5 kilograms. So write the mass is equal to 5 kilograms, and has a back spin of 10 radian per second. It means that initially the angular speed was 10 radian per second in this direction, is given here. And the velocity 4 meter per second. So that's V1. I know it's written here as V0, but just I will use 1 as I did in the equation before. 4 meter per second. Determine the time back spinning stops, when it stops. So it means when it stops, we expect that omega 2 will be equal to 0, right? When it stops. And the velocity, so they want the velocity of its center. They want to find the velocity V2. If the center, it means G, this point. And it's given the coefficient of kinetic friction between the ball and the alloy, 0.08. This mu, as you know, the coefficient of the friction, 0.08. And for simplicity, we're going to use G. The acceleration of the gravity, it's 10 meter per second square. So we, of course, we're going to apply the principle of moment and impulse, which you can say that L1 plus the impulse be equal to L2, the initial momentum plus the linear impulse caused by the external forces be equal to final. And of course you can break it to x and y component, as you know that. Just make it simple. And also don't forget we're going to use that the initial angular momentum plus the angular impulse would be equal to final. Simple still. As in any problem that we solve in this course, we should first find the variables that we always need, like we need to find the weight. So the weight is equal mass times g. The mass is equal 5 kilogram, and g we assumed equal to 10%. So we have 50 Newton. And the moment of inertia, that's a ball like sphere. So if you go back and look at the table that you have it there, for the ball, it's equal to 2/5 the mass times the radius square. So you have 2/5, mass is equal 5 kilogram, and the radius equal 0.1 square. Multiply, you will get 0.02 in the unit kilogram meter square. So we got the two variables here. Next, what we're supposed to do, we do the free body diagram. We have the sphere, or the ball, I'm sorry, and you got the center of gravity. That's the weight here. Let me make it just longer here so you can see it. That's the weight, and it's rolling over a surface here. So we expect that we'll have reaction directed upward at this, we call it N. And since it's rolling in this direction, so you have friction force, and moving also in this direction, so you have friction force in the opposite direction, which is we call it F mu. The friction force, as you know, is equal mu times N. So obviously you have to find N first. We calculated the weight of this ball equal to 50 Newton. And so we don't, of course, this ball is not jumping up and down, so it will be balanced in the y direction. So in this case, you can say that N will be equal to the weight, which will be equal to 50 Newton. So already know the value of this reaction force N will equal 50 Newton. For FU, you cannot calculate it now because, or you can do also here. Well, so let's find the friction force. The friction force is equal mu N, but this is the x direction, the positive x direction. So this one in the negative direction. So if you can say write negative or minus mu N, which is equal to negative 0.8. Oh, that's 0.08. Sorry. 0.08 times N. Already found N is equal 50. That will give negative 4 Newton. So the friction force is equal to negative 4 Newton. When we find something here which is equal negative 4 Newton. Already found N is equal 50. So now we're supposed to find the moment also, the external moment. Well, the moment, if you look at the moment here, N and W passing through G, so we cannot include these forces for the moment equation. The only one that cause moment, the friction force. If I just write to make it clear here, that's the friction force F mu, and this is G. So the distance between the center of mass and this one, a perpendicular distance, that's equal to the radius, which is equal 0.1 meter. So you can calculate the moment. It's external caused by the friction, and that's why also it's negative. So you can say that the moment, and I'm saying external moment, that's equal to the friction force times the perpendicular distance, which is equal R. F mu is equal negative 4 Newton, and R equal 0.1 meter, so to equal minus 0.4 Newton meter. So we got, so we prepared everything that we need for the moment and impulse analysis. Now let's look for the x component. For x component, the equation of the principle of moment and impulse, that will be L. We write L plus, I just like to to write in this way first. This is the initial, and this is the final, and we are talking about the x component. All right. We don't have y component, we have only x component. So how can we find the linear moment in x direction? If you remember, it's equal the mass times the velocity. All right, the mass times the velocity. Of course, when I talk about the velocity, I'm talking the velocity of the center of mass at position 1. All right, and what about the linear impulse? Linear impulse, it's caused by the friction, right? Because this is the friction force applied to the system here and in x direction. So it will be the force of the friction. How we find the impulse, let me remind you. We say always the impulse, if the force is constant, we say that the force time what? Time delta t, the period of time where it applied. Well, we say that it starts from 0 time, so you can say that t1 is equal 0 and t2 is equal t that we try to find. We don't know what's the value of it. So it's from 0 to t. So that would be from the final is t and the initial is 0. And what about the final momentum here? Would be the mass also time the velocity of the center of mass, the final one, v2. This is unknown. We know the first one, v1, it was given. v1 is equal 4. So, and the mass equal 5. So we can write the mass is equal 5 kilogram. Let me write the units so we know what this represents. That's the kilo. And the velocity is equal 4 meters per second. That's represent the linear momentum at t equals 0 plus the sum of the impulses. We have only one force, F mu. F mu is equal -4 Newton. And the time, we don't know the time. T minus 0 is equal t. That represent the sigma of the impulses equal. The final, the mass is equal 5 kilogram. Time the velocity at the final time, we just write v2. That represent the momentum, the final one. So just let's simplify the equation. So you have 20 minus 4t equal 5v2, and that would be equation number 1. For y component, if we try to write y component, we don't have any velocity in the direction of y. When can you find the y component? If I said that the ball is moving in this direction, so we can make resolution x and y. But in this case, it's simple case. It's the velocity, is given in this direction only in x, so you don't have y. So what you'll do? What next you need? You need. We did the linear momentum. We do the angular one. So how you do the angular one? Oops. The angular momentum. And instead of L, you have H. Of course, you don't have components. H plus sigma angular impulses, or the torque, equal to H. This is the initial and this is the final. Well, how you find the angular momentum? We know that it's equal to I, mass moment of inertia at the center, times omega 1. The final, it's Ig times omega 2. And remember, it will be rest, so omega 2 will be equal to 0. And the external momentum, excuse me, that's caused by the friction force. This is the one that caused the moment, external moment. So that will be equal to the moment times t, because t minus 0, as we did with the force exactly. Look at the force here, the moment, okay. So let's just substitute Ig. We already calculated for the ball. That was equal 0.02. So we have 0.02. And omega 1 also was given. Initial one, that was 10 radian per second. 10 radian per second. Plus the moment, also we calculated, is equal to -0.4 and negative 0.4 times t. Minus 0 is t. And that would be 0 because we said omega 2 is equal to 0 times ij will be 0. So let's simplify the equation. So this equation will be 0.2 minus 0.4t is equal 0. Then you can find t from this equation, right? You can find t. So t will be equal to 0.2 divided by 0.4, which is equal to 0.5 seconds. So you can say it stop after half second. So t is equal 0.5 seconds. So that was the first requirement. Second requirement, we want to find the velocity for stop. So I go back to equation 1 and I write it 20 minus 4t, and already found t is equal to 2.5. I substitute, so this value I just got it from here, equal to 5 vt. This equation, the only unknown vt, I solve for vt by substituting, then you'll find that v2 is equal to 3.6 meter per second, and then we'll be done. Very simple concept if you follow the same step. I hope that was helpful. Thank you.